Hey there, welcome back to lesson 10 of our Python Bootcamp. And this lesson is a very important one. This one we're going to talk about Python as an object-oriented programming language. And Python's not the only language that shares these attributes. Many languages are object-oriented programming languages, but Python in particular does some really amazing things in OOP, or object-oriented programming. And we're going to cover those in this lesson today, and I think you're going to really enjoy it. So object-oriented programming is one of the most efficient ways to write software. Object-oriented programming allows you to write what are called classes that represent real-world situations or things. And then you create objects based on these classes. This makes complex programming much more simplified and easier to read. This is important for both you and others that might be working on your programming projects. So let's take a quick example of, well, what's an object? Well, an object, as an example shown here, is something that contains both properties and behaviors. In this case, we have an object that has the properties of name and age, and also includes the behaviors of walk and talk, which will also be referred to as methods later on in the course. So what are classes? Well, think of classes like blueprints for creating objects. We can create many unique objects from a single class. And the process of creating an object from a class is called instantiation. Now let me give you a quick example here. Let's take, for example, on the left side, we have a class, and the class name is dog. Now the dog has properties and behaviors. Its properties or attributes are name, color, and breed. Its behaviors or methods might be something like bark, roll over, or wag tail. So let's instantiate from this class of dog two objects. Okay, we have object 1, which is dog1, which has the properties of name, color, breed of Buddy, Yellow, Lab. Okay, and then we have dog 2, which has the properties name, color, breed of Jade, Brown, Boxer. They all share the same behaviors in this instance. So this is a great example of instantiating classes, building a blueprint that will then be used for many objects along the way through your program. We've already been using classes and instantiation without even knowing it. For example, let's take the string class. Remember how we could write out strings and then write the method .format to append things like variables back into the string, as we see here? This is the string class using the method format in order to accomplish something with the string. So even though we didn't know we've been using instantiation or classes or objects before, we have been this entire time. They've just been built in kind of under the hood Python objects that we've been using. All right, so back to our example of classes with our class on the left and our objects on the right side. So how do we create these classes and then instantiate the objects? Well, let's jump into our Jupyter Notebook and start coding. All right, so in our Jupyter Notebook, we have a predefined class that we need to create. So we're going to create this class called dog, and it's going to have some attributes of name, color, and breed, and it's going to have some behaviors or methods called bark and roll over. So how do we create the class? Well, we use the class keyword, and then we give a name to the class. This name can be anything you'd like. In this case, we're just going to call it dog. And this is not any specific dog. This can be any dog. So this is our class dog. And then we need to create what is called the init constructor method for the class. Sometimes this is where it can start to get a little confusing. All I ask is to stick with me And I promise I'm going to explain how all of this works. So I'm going to write out the class. Okay, it might be confusing at first, but then we're going to go through the class and explain exactly what's happening. So I'm going to define a function. This is a Python built-in function and therefore begins and ends with double underscores. And this function is going to take 4 parameters. The first one, and always the first parameter with an init function, is the self attribute or parameter. And then we're going to include our 3 other attributes that we have up here. So we're going to include name, color, and breed. Okay. And then inside of this function, we are going to initialize the attributes by doing the following. Self dot name is equal to name. Self dot color is equal to color, and self dot breed is equal to breed. Okay, that initializes the class. You probably still have some questions here. We're going to come back to them in just a minute. Next, what I want to do is define the methods of this class. In this case, we have bark and rollover. So we're going to define the bark method, and we need to pass it self. Okay. And then this bark method needs to do something. In this case, let's just print something out. How about we print the name of the dog? So let's print self.name says rough. Okay, so the name of the dog says rough. Okay, all right, that is the bark method. Just an example. Let's create a rollover method. We need to pass back in the self because it's going to allow us to use it in this method. So we're going to say self.name rolled over. Okay, that's it. That's the very simple example of a dog class. All right. So let's go through and explain what just happened, especially with the init and the self parameter. So it does look strange, but the init function is initializing the attributes of the class. Okay. And again, the reason why we have underscore underscore before and underscore underscore after is to protect any other methods that you might have used in your code in case you used a method called init. It's just protecting it as a Python only method so that it does not conflict with any of your code. That's the reason why we have double underscores. Okay, so the init constructor method in this case includes 4 parameters: self, name, color, and breed. The self parameter must be a part of the method definition, and it must be the first parameter always in this method definition. And what it's going to allow us to do is by providing self any time that we instantiate the class to an object, it will now take on the self attribute. Later on in the code, you see that we have self.name takes on the name argument. We're assigning self.color, the color argument, and we're assigning self.breed, the breed argument. So this allows us now to use self anywhere else in our class instance. So we can come down here now and pass self from above, and we can use self.name. We can do the same also now with our rollover method. We pass self and also can use self.name. So that is the purpose of the self parameter, is to be able to pass on that self attribute onto instantiated objects later on. Now, how do we use this class? Well, now it's simple to make it an instance of the class. All we need to do is assign it a name like my dog equals the class name of dog with the needed attributes of, let's say his name is Fluffy. He is brown and the breed is a boxer. All right. If I do that, hit Control Enter, I now have a new object called my dog, and it is taking on all the class attributes that I've created. So, for example, I can start accessing attributes from this object. I can say, what is my dog.name? Let's print it out. Print my dog.name. Fluffy, right? I can do the same, of course, with the color and with the breed. Okay. So that is how we access the attributes. Now, with the class, we have some built-in methods that we can use. We can call my dog dot bark. What happens if we call my dog dot bark? Let's run it. All right, there we go. It ran this function or method inside the class. The self.name plus says rough. So Fluffy says rough. The same works here for my dog dot rollover method. And Fluffy rolled over. Great. So that's how we call methods out of the class that we have created. All right. All right. So what about setting a default attribute value? So getting our original class, I'm going to copy this down here just so we can follow along. So if we wanted to, right now in our init method, we are assigning these 3 attributes. What if we just want to have also an attribute that defaults at a certain value that we don't pass to the class when we create it, okay? When we create the object. So we might have something like self.age is equal to 0. What this means is every time we instantiate an object from this class, we are going to need to pass it name, color, and breed, but by default, age will always begin at 0. And then we can modify that value later or increment it yearly, however we decide to do that. But in this case, we've set a default value of self.age equals 0. So if I come down here and I, again, call this, let's call this dog1 is equal to the dog class. And again, I'll still use Fluffy. Not Fluggy. Fluffy, again, is a brown lab. We did a boxer. Okay. Now, notice how we didn't assign it an age. But if I print dog1.age, there it is. The age is 0 because we've assigned that default value of 0 to the class. Okay. Well, what if we need to modify an attribute in the object? Very, very easy. We can say dog1 dot age. We can give it the actual age. This dog is actually 3. That's it. That's all it took. So now the object dog1, if we are to print the age, and I'll even comment this out. There we go. The object dog1's age is now 3. Okay. So we've, now the original class didn't change at all. We can create another class and the default value still remains 0, but for the object dog1 that we created from the dog class, its age is now 3. Okay. All right, what about modifying an attribute's value through a method? All right, let me give you an example of how this might work. I'm going to go back up to this class, and we will create a new method. I'm going to call this one setAge. Okay. We're going to pass in self, and we're also going to pass in the argument of age. All right, and what we're going to do here is assign self.age. So again, we're using self. We're going to assign self.age equal to the age argument that we provide in the method. I'm going to show you how this works here. All right, so we got setAge, and then again, we will just do this. I'm going to run this entire thing. So it ran this new class. It created again dog1 object and printed the dog1 age as 0. Okay, great. Now watch this. If I come down here, we're going to modify the age using a method. All right, so how that works is we can say dog1 dot set age method and the new age 7, and then let's print dog1.age. There you go. The age is now 7. So instead of explicitly doing it through dog1.age equals whatever, which is another way to do it, we used instead a method to make the change. dog1.setAge7, it then ran the code, the method code here, which essentially just very simple, just assigns the age here to self.age. Okay. Now you might be wondering, well, why in the world would I do that rather than just write dog1.age equals this? Well, this is a very simple example. Maybe you want to also write to logs and say, this user did this when they did this, and then make the change. Well, you can write all of that code in this block, but the code can be executed using the method of setAge. Okay, so that's how you can modify an attribute through a method. Okay, so let's talk about class inheritance. So let's say, for example, that you have a specialized class based on another class. Then you can inherit the attributes and methods from a class to a new specialized class of that class. Let's say we're taking our dog class and we want to create a specialized class of just dogs that come from dog shelters. Okay, so these dogs that come from dog shelters will have a few other attributes that a normal dog maybe won't have, like are they healthy and are they chipped, things like that. And I understand any dog can be chipped, but I'm just making an example. All right, so how can we create a specialized class or a child class from our dog class, which is our parent class? Okay, well, to do that, we could create a new class. And by the way, how you write out a class name is in what's called camel case or title case, using capitals at the beginning, unlike snake case, which we've already discussed, which use underscores and lowercase letters. So that's what differentiates classes from, like, essentially the object names or other names. So we're going to create a class called dog shelter, and we're going to base it on dog. So when we write out our class definition like this, we are inheriting the attributes and methods from the class dog into a specialized child class called dog shelter. Okay, and then like above, we are going to define the init method, and we're going to still include self, just like above. Right here, we're going to include self, name, color, and breed. Okay, and then we are going to initialize these attributes, but in the child class. We can pass everything from the parent class to the child class using super, which could also be referred to as superclass. We do that using super dot underscore underscore init, like above. And then we call our attributes from our parent class. Name, color, breed. And we've already called self. Okay? Now this in itself will already create our specialized child class of dog shelter, but I'm also, before I initialize, I'm going to add a couple more. Besides name, color, breed, we're going to add, let's do if chipped, and by default this is value of no, and also is healthy, and by default the value is yes. Okay, now if we run this, we now have an inheritance class called dog shelter based on dog with some additional attributes included. Now notice how we didn't put any methods in here, yet if I create a new variable called shelter dog and I create that off of the dog shelter class. All right, so creating a new class of a dog named Chloe. Chloe's a yellow lab. All right. Now, if I do that, let me show you what happens if I start to write shelter dog dot bark. Look at that. Notice how we didn't have to put any methods of any kind in this dog shelter class, yet the bark method exists. And that's because using the using inheritance, we took on all of those methods from the original class, and they now are part of our dog shelter class. So that's great. So now we might do something like, well, shelter dog, if chipped, well, Chloe is chipped. Okay. And shelter dog. We don't even have to say if healthy because she's healthy. Okay, so shelter dog if chipped is yes. So she is a chipped, healthy shelter dog. So that's how class inheritance works. So what about importing classes? Well, if you've been part of our previous lessons, you learned about modules and how you can separate functional Python code in different files, and then using import, you can import those into your program. This works exactly the same. If you are to create a class like this, class dog, in a separate file, and perhaps you have many classes, perhaps you're building a role-playing game and you have lots of different breeds, and you have different classes of people, and or orgs or whatever you have in your game. So you have a file of all these classes, and that way, and you don't want to put them into your actual programming code, you can put them all in their own file, and then you can just import. Let's say that this is in a file called dog types. So you can import either like we did before. In modules, you could say, hey, I need to import dog types. Okay, and then you can say my dog is equal to dog types dot dog, and then your attributes. Okay, so you can call it straight out of the file using the file name dog types and then the class name of dog. Okay. You can do it exactly the same. You can also use the from, just like modules. You could say from dog types import dog, and that would import just the dog class but not any other class in the file. Or you could also say from dog types import star, and that will import all of the classes and functions, if there are any, in that file for use as well. Now, there are some caveats to doing this. If you have not yet seen the Python modules video, please go see that video, because importing and exporting functions and classes is the same, and that should be able to answer a lot of your questions there. So again, just like functions, you can separate your classes into separate files and then call them into your main program at any time, and makes it very easy to read and to debug any future problems that you might have doing that. So that's importing classes. Great. We went through a lot in this lesson. Object-oriented programming is a big part of Python. I'm really glad that you joined us on this video so you could start to learn the concepts, and we're going to start to learn more and more about object-oriented programming and how it's used in later lessons. So stay tuned for our next lesson, where we're going to begin discussing Python files and exceptions. And I'll see you there.